Welcome to a new deep dive. We're tackling dynamic programming today, using excerpts from Dynamic Programming, a computational tool. Have you had a chance to take a look?
I have, yeah. It's amazing how relevant this stuff still is. And it's not just about code. It's a way of thinking.
Right, and that's what we're going to unpack today. I have to admit, though, when I hear dynamic programming, my mind goes straight to, like, complex algorithms.
Yeah.
Is there a way to explain the core concept, even for someone who's not a programmer?
Absolutely. It's all about breaking down big problems into smaller, manageable ones. Imagine you're building a massive Lego set. You wouldn't try to assemble it all at once, would you?
No way. You'd build it in sections.
Exactly. That's the essence of dynamic programming. We solve these smaller subproblems, and here's the kicker, we store the solutions. So if we encounter the same subproblem again, boom, we don't waste time resolving it.
Like having a cheat sheet for decision making. I like that. So instead of constantly retracing our steps, we're being efficient about it. The text mentions optimal substructure and overlapping subproblems as core principles. Any chance we could break those down a bit?
Sure, think of optimal substructure like this. The best solution to the whole problem relies on the best solutions to its parts. Just like with the Lego analogy, if one section is weak, the whole thing is compromised.
It's about ensuring that every decision, every building block, is solid to support the overall solution. What about overlapping subproblems?
Ah, that's where things get really interesting. It basically means that when we break down a problem, we often encounter the same smaller problems multiple times. Dynamic programming says, hey, we already solved this, let's just use that answer, streamlines the entire process.
So instead of brute forcing our way through, we're being smart about remembering past solutions. Makes sense. But how do we actually put this into practice?
That's where dynamic programming functional equations, or DPFEs, come into play. They give us a structured way to approach and solve these problems. They're like the secret sauce.
DPFEs. Those sound like our mathematical blueprints.
Precisely. Imagine a DPFE as a recipe with a few key ingredients. First, we define the state, which is our current position in the problem. Then the decision, the choice we make at that state.
Okay, so we're figuring out where we are and what we can do next.
Right. Now, each decision has a reward or a cost associated with it. This helps us figure out which path is the most advantageous, which choice gets us closer to the best outcome.
So we're evaluating the consequences of our choices at each step.
Precisely. And finally, transformation, how our decision moves us to a new state. This might seem a bit abstract right now, so let's ground it a bit. The text mentions the linear search problem. Maybe we could use that as an example.
Okay, yeah, let's see how this recipe works in action. What's the linear search problem all about? So is this linear search problem like trying to find something specific in a messy drawer, like we were talking about earlier?
Exactly. Instead of just rummaging around, dynamic programming helps us figure out the absolute best way to organize that drawer so we can find what we need quickly. It's about making the search as efficient as possible.
Oh, I see. So it's not just about finding a solution, it's about finding the best solution, the most optimal one. So what other kinds of problems can dynamic programming help us solve?
Tons. Think about those map apps we all use. They use dynamic programming to get us around traffic jams and road closures. They're constantly recalculating to find the fastest route.
Wow, I never realized that's what was going on behind the scenes. That's so cool. So it's optimizing our travel time in real time.
Exactly. And it's not just about distance. We can factor in time, cost, or really any other variable we can think of.
That's pretty powerful. Okay, the text also mentioned the knapsack problem. That sounds intriguing. What is that one all about?
Okay, imagine you have a knapsack, but it can only hold so much weight. And you've got all these different items, each with its own value and weight. The knapsack problem is about figuring out which items to pack to maximize the total value you're carrying.
Oh, so it's like, are we talking about souvenirs here, or are we talking about, like, essential survival gear?
It could be anything. The cool thing is, we define what value means in this situation. It could be money, sentimental value, usefulness, whatever's important in that scenario.
Huh, that's really interesting. So it's all about making the most of what we've got, maximizing utility within certain limitations.
You got it. And we can apply that to so many things, from packing a bag to making big investment decisions.
Okay, that's really cool. What about this edit distance problem that the text mentioned? It sounds like it might be related to spell check or something.
You're right on the money. Every time you make a typo and autocorrect swoops in to save the day, that's dynamic programming at work.
Oh, wow. So it's analyzing the words, figuring out the fewest changes to make it right.
Exactly. It's like the algorithm predicts human error and then swoops in with the fix.
That's amazing. The text also mentioned the Tower of Hanoi puzzle. Can dynamic programming solve that too?
Absolutely. It doesn't matter how many disks you have. Dynamic programming can find the most efficient way to solve it. It's a classic example of how to break down a complicated problem into smaller, more manageable steps.
So it seems like dynamic programming can be used for a lot of different problems.
Yeah.
But how do we actually use it? I mean, do you have to write complicated code every time?
Well, the text mentioned a software tool called DP2PN2 Solver. It's a special kind of program generator that takes the headache out of coding for dynamic programming.
DP2PN2 solver.
Okay, that sounds intense. What does it do exactly?
You basically feed it a description of your problem, like a dynamic programming recipe, and it spits out the code that solves it.
So it does the hard part for you.
Exactly. It uses something called Bellman Nets to visualize the problem, kind of like a flowchart, showing all the states, decisions, rewards, and how it all connects. So instead of writing code, you're creating a visual representation of the problem, and the software handles the rest.
Yep. DP2PN2 Solver bridges the gap between the theory and the actual doing.
DP2PN2 solver sounds pretty game-changing for using dynamic programming in the real world.
It definitely is. And what's really cool is that this isn't just for computer science.
It's a whole different way of thinking about problems in general, isn't it?
It really is, like breaking down a challenge into smaller steps and then looking at the possible outcomes and choosing the most efficient path forward. Remember that state decision reward transformation thing we talked about?
Right. Like when I'm planning a road trip, I need to figure out where I'm stopping for snacks.
Exactly. Now imagine using that same kind of thinking for other parts of your life. Like what if you could use that framework for any scenario? What problem would you want to solve with dynamic programming?
That's a great question. I'm already thinking about how I make decisions in general. Could I be more deliberate about those decisions? Maybe think more about the long-term impact of each choice I make?
I think so. It's about recognizing that these principles can help us make better decisions in all sorts of situations.
This deep dive has been amazing. Dynamic programming isn't just some abstract computer science thing anymore, and a powerful tool.
It is. And honestly, we've only scratched the surface here. There's a whole lot more to explore with dynamic programming.
Well, I'm definitely ready to dive in deeper. I'm already feeling inspired. Thanks for this.
My pleasure. Just remember, the real magic of dynamic programming isn't just in the algorithms themselves. It's about how those algorithms can help us make smarter choices and solve real-world problems more effectively. So keep that curiosity alive. You never know what other applications you might find for it.
Great advice. And to everyone listening, thanks for joining us on this deep dive. Until next time, keep those minds curious. There's always something new to learn.